The essential question for today is, how do I solve a system of equations using the elimination method? So we're using two-column notes just like we did earlier this week. So the steps are on the left and we're going to show those steps on the right. So the first step on the left asks us to make sure that both of the equations are stacked, is what I like to call, or lined up. And what I mean by that is look at the structure of the two equations. These two equations are both in standard form, which means that they're lined up. So the x's are on top of the x's, the y's are stacked on top of the y's, the equal signs are stacked on top of each other, and the constants are stacked on top of each other. So this just tells me that this is an excellent equation that I could use for elimination to make things a little bit more simple than solving for substitution. So step one, check, they're stacked, everything's ready to go. Step two, I need to look at the numbers with the variables with x or y and see if any of them are the same. So I am I'm looking, and 2x and negative 2x are almost the same, right? This is positive 2, this is negative 2. So that means that step 2 is I'm already there. So yes, decide if you could add or subtract to cancel it out. So if I subtracted 2 minus negative 2, that would not make 0. That would make 4. But if I added 2 plus negative 2, that's going to make 0. So I'm going to add these two equations together. I'm going to maybe write that down. Adding would cancel the x's. So that's the strategy I'm going to use. I'm going to add those two equations together. So I've got 2x plus 3y equals 11, and I've got negative 2x plus 5y equals 13, and we're going to add these two together like elementary style vertical addition and subtraction. So I'm going to add each row. So I'm going to say 2x plus negative 2x gives me 0, which is what I wanted to do to cancel the x's out. And then I need to do the next row. 3y plus 5y gives me 8y. And 11 plus 13 gives me 24. So my x's are canceled. So we just did steps 1, 2, and 3, right? We've solved, but we're not quite done. How do we get y by itself? We're going to divide both sides by 8, and that's going to give me 1y equals 3. So I have one of my variables solved for. I know that y equals 3. And maybe I want to mark that we canceled these x's out by using addition. All right. So now we're going to do step 4, which is now we know what y is. I'm going to plug it into either the top equation or the bottom equation. It doesn't make a difference, but I'm going to plug it into one of the original equations. So let's go with the first one. 2x plus 3, but now I know 3y equals 11. But now I know that y has a value of 3, so I can plug it in for that. 2x plus 3 times 3 equals 11. So I've got 2x plus 9 equals 11. Subtract 9 from both sides. 2x equals 2. Divide both sides by 2. X equals 1. So now I have an x value and I have a y value. So that means that that's the point on the graph where these two lines cross. So step 5 is to write that solution as an ordered pair. So x was 1, so that one goes first. And y was 3, so that one goes second. And that is the solution. That is the point where those two lines meet. So this one was a really good substitution problem or elimination problem because everything was stacked and the x's both had 2. One was a negative 2 and one was a positive 2. That was like the perfect problem for elimination. This next problem is a little bit different. So step 1 says to make sure they're stacked. So We're looking 3x and x, they're stacked on top of each other, sweet. Y stacked on top of y equals stacked on top of equals, -1 stacked on top of -1. So this is set up perfectly for elimination. Step 1, make sure they're stacked. Check, they are stacked. Step 2 now says look to see if their numbers are the same. Is 3 the same as 1? No. Is 5 the same as 2? No. So since the numbers aren't the same, I need to multiply one of the equations by a number that would make it the same. So I could either, like if I tried to multiply 2, I'd have to multiply it by 2.5 to make it equal 5, and that seems kind of messy with decimals and fractions. But I could multiply 1x times 3, and that would equal 3. So that's what I'm going to do. I'm going to multiply the bottom equation by 3 to make those the same. So then I'm going to have the top equation stays the same, 3x plus 5y equals -1, but the bottom of equation, I'm now going to multiply by 3. Everything in that equation. So 3 times x is going to give me 3x. 3 times 2y is going to give me 6y. And 3 times -1 is going to give me -3. So now both equations are stacked and the x's have the same number, so they're going to cancel. So now I need to do question 3, or step 3. Should I add them to cancel them, or should I subtract them to cancel them? So 3 plus 3 would give me 6. That would not cancel into 0. But 3 minus 3 would give me 0. So I'm going to subtract both of these equations so that I can cancel out my x. So every column, I'm going to subtract. So 3 minus 3 is going to cancel out and give me 0. 5y minus 6y is going to give me -1y. -1 minus -3, this one's a little bit tricky. When you subtract a negative, you're really adding. So -1 minus a -3 is really +2. Then I keep solving. I'm going to divide both sides by -1 so I can have positive y. And I get y equals -2. All right. Then now that I know what y equals, I can plug it into either of the equations to solve and get x. So I'm going to plug it into the first one, 3x plus 5, but now I know that 5 is 2, -2, equals -1. So I took this equation and I plugged -2 in for y. And so I'm just going to go ahead and solve that. 5 times -2 is -10, so I have 3x minus 10 equals -1. I'm going to add 10 to both sides. And I will leave me with 3x equals 9. Everyone's favorite last step is to divide both sides by the number with x. And I'm left with x equals 3. So now I have an x value and a y value. My last step is to write it as an ordered pair. So x was 3, x comes first, and y was -2. And this is the solution. There are problems where it's hard to find a number that would multiply both. You might have to multiply both equations by a number. And I think there will be some opportunities to practice that on the formative that we will do tomorrow. So I hope these notes are helpful, and I hope they help you get better at elimination.